Okay, so let's talk about your, now since we have all of that cleared up, hopefully, let's look at this. See how this is like going around and around? Oh, I lost one of my arrows there. Around this? It is accelerating because it's changing direction. Which direction is it accelerating? I want you to remember that your net force, this is Newton's second law, is equal to your mass times your acceleration. So think about when you're a little kid, or if you want to go out and like grab, like if you'd run past a basketball goal or the monkey bars, like if you run in a straight line, like see, like this is the top view. Got a basketball goal, this is a little kid's head, okay? They're like running. I guess that's them running. This is like you're looking down on this. And teaching elementary school, a lot of little kids will run up. This is like the shoulder dislocator. And they like run this way, straight line, their velocity's this way, that would be better. And they run, and then they'll grab the pole, and with this arm, and then, let me erase. Hopefully knows what, most of you probably know what happens. They're running a straight line, they grab this pole, and then they start to go in a circle, and it's a whole lot of fun, especially if you can kick up mud or gravel or something on your friend. Okay, so they just grab the pole, they're running, and if you ever did this, or if you want to try it, you can feel it in your shoulder. I mean, little kids dislocate their shoulder doing this like all the time. And so it's kind of like you go around in the circle. Now, you might be feeling like if it's you, it's kind of pulling you to the outside. Think about you and the whatever you're spinning around system. Okay? If you do that together, this is actually pulling you around the center. And if you know your net force or whatever your big force or your ultimate like force that's working on you that's causing acceleration, you're going to go in the same direction. So if this pole thing is pulling you towards the middle of the circle, guess which way your acceleration goes? It also goes around the middle of the circle. See, and if you're looking, think about it like up here, this is your acceleration. Up here, if the red is your velocity, then if you get kind of pulled towards the center, if you're running this way, it's going to kind of turn you a little like this. And see, and again, that pulls you towards the center, and it just keeps going, the green one's acceleration. You just keep getting pulled towards the center. And your force is going to go the same way. That's a hint for tomorrow. All right, so that's kind of how that works. So your acceleration is always going to go towards the center. Now, let me tell you for this equation, there is an equation. And by the way, there's a word. And it means centripetal towards the center. Okay, so centripetal towards the center or around the center. You get pulled or accelerated around the center. So this is going to be your centripetal acceleration, A sub c. Now, this one is not one I'm even make physics C proof. To really do it, you have to do it correctly. You pretty much have to use a lot of trigging. You should use calculus. Some people don't. I think you should. So I'm not going to prove this one for you. This is going to be one of the very few I give you a memory trick. So it's kind of gross, which is good. You'll remember it, hopefully. So you're walking in the desert. It's really hot. And you look down at your feet because you smell something. It's just the stinkiest smell you have ever smelled. And this isn't going to be a very good picture. I'll find more upsetting pictures later. And what you see is this disgusting, really, really nasty dead rat. It has probably been dead for a really long time because it's like oozing all kinds of nastiness. It's stinky. It's a dead rat. Okay, it's like got pus and maggots, all kinds of nastiness. Okay, coming out of it. So this is a dead rat. It is on the bottom. So look down here. You would have your, in the denominator, your R for your disgusting dead rat. Now, let me think. There are birds that don't think that's nasty with like maggots and stuff coming out of the eye, just this really nasty dead rat. They're birds, and if they're, you kind of see them like this. This is a really ugly drawing. They like to fly in circles above stuff. Hey, guess what those are called? They look like seagulls here. I'm sorry. I'll find better pictures. These are vultures. Okay, and there's two of them, so we go vulture times vulture. So that would give you vultures. Oh, by the way, I'm going to write a little C here because they fly in a circle. Okay, vulture. So vulture times vulture, vulture squared. So this is V sub C, because they fly in circles, squared. This is your equation. So V sub C over R. And that one just memorize. If you really want a proof, talk to me, I'll give it to you. So that is your centripetal acceleration, which is towards the center. And that's all I'm going to do for tonight. Just kind of, you might want to see how these two things go together. And some of you did that in class, some of you didn't, but that's important to know.